Okay, so this is an informal tutorial of how to use Scene, which is the software that works with the Faro scanner to help record laser scans into the post-processing workflow. When you open the program, the first thing you see is a project's overview. You can either create a new project, open an existing one, look at the project history from a certain file, or even transfer to, say, another software workflow. I just created one. One thing to note, you obviously want to use some level of coordination and consistency with the project naming. I'm going to go ahead, I'll open this, and this brings us to the main page of the project. Actually, that's not the right one I wanted to look at. So one good trick to learn is if you're trying to find the most recent project, see I have a lot of similarly named projects. I'll go to modified, and I just created one just a moment ago. So this represents sort of an acronym that I and the team that's working on this project understands. Open this file. This assumes you've already gone through the laser scanning process on site and you've uploaded the photos for your own work sort of workflow. I have taken the original scans, which are these highlighted scans here, and I have downloaded them off of our server to my local desktop, so they're a lot quicker to work with. What you can see is the name of the scan is just the output that you put in when you're setting up a project for laser scanning itself. So that's pretty important to recognize. If you're working on multiple floors or multiple areas of a floor, you want to make sure that you set the name of the project and the subfolder within the project according to the area so that I know exactly which files pertain to which floor and which area that I'm working with. So moving forward, I'm now in this project sort of dashboard. Once I begin processing and registering, this information will update. I just want to click on the next tab. And all I'm doing now is I'm dragging and dropping these scan file folders into the software. It should give me a good reading saying that it was able to import them successfully. Occasionally that might not happen. Try dropping them in there again, and sometimes doing it twice will make a difference. I see these all here. If I had other scans, I could import them, but I'm just working with these today. You not necessarily need to worry about the other options on the importing category for this specific exercise and tutorial. I'm going to go ahead and I'm going to move to processing. So on the processing tab, you have two new menus. You want to click on the process scans, and they have not been processed, so they have the red designation. Click on the scans portion up on the right hand of the screen. It now shows as green, and go ahead and click the start processing. So we're configuring the setup. For the most part, this is going to default set up the way that you want it. If you've used checkerboards or spheres when you were scanning, you want to make sure that you have the appropriate one checked. For this project, they use checkerboards. All this does is it helps the software self-identify these locations for you. You'll get some false positives, so you do want to verify that on your own. If you were finding spheres, then you want to make sure you know what the radius of that sphere is and plug that in. It helps the software also locate that based on size. You can get false positives, say a balloon or a soccer ball or something was in the screen. It will also pick that up without knowing. One thing that you can do here is do a distance filter. So what that does is if you've got stuff that's way far away out in the off in the horizon, it's not going to necessarily capture that. It can cut down on some of the file size. I'm going to go ahead, I'm going to start processing. Now this will probably take, I would guess, 5 minutes to 10 minutes, but it's based on the approximate speed of your computer processing and the network that you're using as well. This is a software program that uses the internet to open and configure itself. So while it's doing this, a couple things I'll mention, just some best practices when you are laser scanning. You want to make sure, again, that you set up the project naming to match the areas that you're working with. If you don't and you keep running, it'll set a new number sequence each scan you do, but when you come back in to post-process, you might not know which scans are floors 3 versus floors 4, or if it's certain areas on one floor, when to stop looking for area 1 versus area 2. Some other things you want to do is if you're scanning the ceilings or the systems above the ceilings, you want to make sure that the ceiling grid is not installed yet. So you work with the field team, the superintendent, someone managing the schedule out on site to ensure that you get in there and scan before some of the equipment and system starts to get covered up. If you're scanning a floor, it's important to scan it immediately after the slab has been poured and the formwork has been taken off. You might get a little bit of an adjustment to the slab once the formwork has been removed. So you need to plan for that. The other reason is obviously trades are going to keep going and they'll start putting stuff on that slab. Any material or equipment on the floor, the scanner can't pick up, and that becomes kind of a dead zone if you're trying to create contour maps or heat maps to validate the flatness of its space. Water, if there's water pooled or ponded on the ground, the scanner won't pick that information up, and it becomes sort of a black hole in the processing part as there's no information. Mirrors will create like a false area. It basically reflects reflects the information that the tripod scanner picks up, and it mirrors that outward. So it would create like a false hallway or a false room by taking that information and projecting it beyond it. Those are some things to be aware of. You want a broom sweep if there's a lot of dust or dirt and you're looking at the floor. It's important that you've got no real obstructions or issues that might make the flooring look like it's a different elevation than it says. So I just processed that, and everything came out green and said that was registered success or processed successfully. That's good news. I'm going to move to the next step. So I have the initial scan sort of stitched together. Now I want to perform automatic registration. What this does is it will now try to stitch them together. You can by default leave the settings as they are established. One thing you can change is top view, cloud to cloud, top view, and cloud to cloud. I would start, if it's a pretty simple, straightforward project, I would just go ahead and try top view and cloud to cloud. Top view basically looks at it from an aerial perspective and tries to stitch them according to someone that would be looking down at the scans. Cloud to cloud uses the information between each scan and the points that are there to help tie together. So this is the most detailed version of doing that. There's also target based. That would be if you wanted it to just look at some of the targets, checkerboards, things like that that you place down, to my knowledge. So you use top view and cloud to cloud. Hopefully it will register correctly. I'm not adjusting any of these settings, but I do know that compass and clinometer are turned on. So this will also take probably a similar amount of time as it did to process initially. So in this time, I'll also mention if you are scanning overhead systems, remember the tripod and the scanner can only see from the point of view that it's standing. So you want to make sure that you get on multiple sides of objects, whether they're on the ground or above you. A large duct, if you're scanning on one side of it, it's not going to see the immediate area adjacent to the duct on the other side. So make sure you set those scan locations in areas that can capture all of the information. It's important to have good overlap in order to help process this, and that requires you to kind of plot out where your scan locations are going to go. The more information or obstructions there are on the site, the more scans you need to kind of help create overlap and stitch them together. Another thing I'll want you to have as a leave behind is this here is by a company called Rhythm, which makes a software for floor flatness. They also have a pretty good workflow of how to set up a project that and do the initial processing. So this is something that can be included and also used as a reference to help along with this video. I will likely walk through it too at certain points to refresh myself, and whenever I am plugging it into control to do floor flatness or help just transform it, it's a good helpful tool to remind myself of the steps. So I'll upload this accordingly with where the video ends up getting saved. So right now the software is trying to stitch them all together. Once it does complete, it'll tell us how successful that effort was, and we can look at the reports and some of the other tools that will sort of give us assurance of how accurate the information is. We'll still want to optimize the scans, which is basically the last step to getting it in a good position for exporting or exploring the information. If for some reason it has trouble registering one of the scans, there's a manual process, which basically you select two different scans and you look for common points in the photos that the scanner takes at the end of its scanning process, and you try to mark points or common planes to help manually tie them together. Boom. So here it creates sort of a little bit of a track history path of where I scanned. What you want to do, if you were the person that scanned, or if you don't know, you want to kind of look at the workflow of how someone may have walked, and there should be a pretty clear sequence of where the scanner was placed. I wasn't the one that scanned here, so I'm looking to make sure that I've got a pretty good continuous sequence across the floor plan. The other thing you want to do is you want to kind of zoom in. You can see all these different colors represents the scan information. One thing I want to do is kind of look at a detail and make sure that there's pretty good overlap of the information between the colors. If say, I'm not sure what this is, but if say this circle here had some green and yellow that was around it, that would mean that the scans aren't really tightly processed. So I would want to maybe reconsider scanning or adding more scans to help stitch it together. Now, I have pretty good confidence that this is a good scan registration based on the sequence and just looking at some of the overlap of the colors. So I'm gonna go ahead, I'm gonna hit they are registered correctly, and I don't need to optimize this because it's stitched together close enough. What I will do is I can go back to the beginning page and I can look at the report, and so it's giving me sort of the details of this. If I look at the report, I can see, all right, so some of the information doesn't seem to, looks like it has a maximum point error of over 1 inch, mean point error. What that basically means is these scans that are listed here may have had some issue. And so typically what you can do is you can optimize this scan to try to counter correct to that. And I thought that we would have that option, but it didn't seem to appear. The inclinometer mismatches, you want to make sure that you're under 2 degrees. And so it looks like this person did a really good job, and the degrees are all under 1. So I know that there's no issue with saying the tripod being non-level. To me, this really makes me believe that there just maybe wasn't enough connections to tie the information together. That could be problematic. So what I was hoping we would have the option to do is to actually optimize it. I don't see what, it didn't give me that option. So I want to be sensitive to that. So if I'm doing more, depending on the output of this effort, if it's just to validate overhead systems for as-builts, you have pretty good confidence that if it's off by an inch or so, it's okay. But if you're doing floor flatness, obviously that makes it a bigger deal. So I don't have a good solution as to why that is, but I can tell you when you are registering, usually you have the option to um, optimize the registration if it's out of tolerance, uh, not acceptable to the project. So let's go ahead. Um, let's continue to move forward for the sake of this training. And right now I can see we've got a 3D point cloud of this scan. These are just millions of dots essentially that are stitched together from the process we just created. A couple things I want to do in the Explore. Um, you can delete out anything that you don't want, and in order to do that, you click on the selection box. This right here under Explore will pop up, and you'll click the select polygon. It's probably difficult to see, but I'm drawing like a yellow um, boundary. Double click on it, and it should highlight in yellow. Again, difficult to see even for me, but these points now have been selected. I'm going to right click and go under current selection, go to delete points. So there's value in doing this because one, it'll cut down the file size. It also cleans up the project before you export or use the information. So let's do that again. Just got a little bit more information here. You do want to be careful that you don't select any of the critical components of the scan. So I try to make sure I have a clear boundary outside of the floor so that I'm not capturing anything unintendedly. Okay, so now that I've completed that, I'm just basically holding the left mouse to explore. The navigate sort of option here is not the best, but you can manipulate the different viewing modes by clicking on the different things. Smart is the one that it defaults to. If I have trouble, I might go back to pan to see something and then go back to smart. Sometimes the center of this will jump somewhere and you have to kind of reset it. The only other thing that you might want to do on the Explore tab, especially if you're going to move forward with looking at the floor flatness, or you want to validate the level of confidence in the scan information, you can click on a clipping box. So it'll predetermine this location. You still need to manipulate it so you can see the different arrows. I'll go to a top-down view and I'll adjust that box to go beyond the area. Also, it's kind of annoying, but the box itself is not sort of orthogonal or linear accordingly. So on the clipping box pop-up that automatically shows up when you click on any of these tools, I'll click on the second one, which is the rotation. This blue circle, I'll move this by clicking on the mouse, and I'll just kind of manually locate it so it looks like it's about in the same position, and then I'll just readjust here. So what this does is it's isolating the information that I want to see, and I use this because I want to see below the overhead. So I'm going to drop this down so that I can look at the scan information. So I can now see below the slab above, and I can assess sort of the quality of the floor in this particular scenario. I don't want this clipping box here because anytime I try to click on something, it's going to click the clipping box. So you can just hide it. So you right click on the left page here under the structure tab, and I'm just going to go visible and uncheck that, and now I can manipulate this and see. So this is kind of neat. You can see this information pretty easily. The other thing you might want to do is see like a 3D view of a scan. So if I go ahead, I click on one of these scans, it's going to highlight that scan location in yellow, so I know sort of where that location is. If I right click and I scroll down to view, I can do quick view, and that's going to load the panoramic image that was taken at the end of the scan. This is really helpful when you're trying to assess what this looks like or where you are. If you do need to manually stitch this together, this is the view that you use, and you'll mark points in order to find common areas on the project. If you're also tying it into control, see there's a checkerboard there, you'll mark a point and then you'll update that. I'll have to show that to you in another segment, but kind of a little bit of a future learning preview there. So that's helpful to capture this information. At the end of every scan, the scanner will take a photo. So you want to make sure that you stay away from the scanner when it's taking that photo. Sometimes people will stand right in front of it, and then if there's information that the person processing needs to see, that person's blocking it from them. So for both your own safety and for the benefit of this workflow, try to stand around a corner or somewhere out of view so that one, the laser doesn't hit you without you knowing, and two, it doesn't block, you don't block the view. So that's helpful to understand sort of the detailed photos of the scan. You'll find yourself really looking back to that when you're trying to stitch it together and you run into some issues with it. So one thing I haven't done yet, which you should do after certain milestones in this, is save. So if I want to, it'll save a history. I might make a comment stating where I stood in case I need to revert back to it. I know which revision this entails. So I'm going to just call this registered, indicating that I've registered the scans and that's the step that I've stopped at. If this goes smoothly, it'll save pretty quickly. Usually it only takes a moment to save. Depending on internet network issues, this can sometimes lag. Looks like it's starting to lag, but fingers crossed this will finish quickly and allow me to move to the next step without trying to fill in some time here. So since this is recorded, you can probably jump ahead to skip this part and just look at the video still to see when the saving command box went down. But I'll leave it running until it's completed. The last thing we want to do is just export the scan. I believe you need to create a project point cloud before you can export it. So we'll complete that step, and that'll conclude the basic stitching process for information. Okay, so I got an error. I can't tell you why that's popping up. All I'll do is maybe my network connection failed. Just last night the company was upgrading the network, so perhaps there's an issue with that. So hopefully this will go away, but if not, yeah, so we'll try that again later. Let's go ahead, for the sake of this training, just create the project point cloud, which is on the export tab. So before I export anything, you can export the scans as they are. You can export the project. But really what we want to do, if we're going to work with it in, say, Revit or Navisworks or another 3D program, we want to create a point cloud. And so you'll see on the export tab, this is grayed out. I need to go ahead and I need to create this. It's going to ask you to save. So let's try saving this again. Hopefully this doesn't have an issue this time. I've actually never run into that problem, that error message when saving. So this is new to me, but that's part of the game. We run into weird technical issues all the time. If for some reason this doesn't work, I'll just kind of talk through the last step, which was at Project Point Cloud, you'll get a command prompt that gives you options of how you want to export that information. In all likelihood, you're going to export it as, I believe, an RCS or RCP file. That is the file extension type that works in Recap. It's also the most familiar with Autodesk. So the file size will be smaller and it'll be easier to work with when you're opening it up in a different program. So that's essentially the gist of it, because I'm trying to teach you how to do this. Obviously, there's issues for me to preventing me from showing you successfully and looking like an expert, but you at least have the general workflow. It's important that you do save early and often, just in case something like this that's happening right now prevents you from saving at a later time. And if you are working with Scene and you're not connected into a hardwire network within PCL Office or Site, you need to be on VPN in order to get this software to work. Do recognize that on VPN things tend to run a little slower, which could be possibly a result of why we're having a little bit of trouble with saving today. Um, I'm gonna let this run for another minute. If it doesn't respond, then I'll at least allow you to work through this process with some of the hiccups that we're experiencing. Just know that you want to click on the Project Point Cloud, which is up here, and you just want to export the project as a recap file. I believe recap is RCP for the drop-down file extension type. Once that exports, that'll take a little while. You'll now can open that software in, say, Revit or AutoCAD or Navisworks, and you could align it to whatever other project data you're working with. If you have survey control, you can also adjust and transform the XYZ coordinates. That just requires you to be fed the control information. That's another tutorial for another time, but hopefully this is enough to get you started. Thanks.